Team FastEddy. Today we are at the RCX 2011 and we're at the Castle booth. We have the opportunity here to talk to Steve.
Yep, I'm one of Castle's engineers. Been with them for a little while now, and we're going to kind of go over the basics of the data logging and what that means for the general health of your system. You know, you might have just hooked up your Baja conversion kit and got it going, and now you've got all this cool information, but we're going to kind of help decode that and find out what it means.
Yeah, I'm pretty slow when it comes to this kind of stuff. So if we could just keep this, real basic layman and show me what I need to look out for, with a quick explanation of what they are, but what we really need to look out for as far as the relevant information to make sure we're running good and clean, and healthy, or not.
Okay. And what we've got here, we've got a data log, and we can do something fancy here. I'm just going to kind of zoom in this area. And what I have opened up currently, I have voltage and current.
That's at the little tabs down on the bottom with your mouse.
We can click those, select them, and bring them back up.
So you can click on more than one to show more than one data set.
Yep.
Okay.
And so this is our voltage, is our voltage of our batteries. And that's our input voltage to the system. And then our current is how much current is being drawn from the batteries. And what we see here, this pack is coming along, and we drew a lot of current that kind of sagged and didn't really fully recover, it looks like. There's a big current spike here in this area. But we've got our input voltage, this is from our batteries, and then we've got our current. And we can also select another thing, it's called voltage ripple. And that's a quantity, it's in volts, and that's how much our batteries are deviating from being a DC source, which means how much that voltage is fluctuating as we're running the motor. When we get a high percentage of ripple voltage in terms of our input voltage, so if we have our battery input voltage, if we're running over 12% ripple voltage, we're in a real bad zone. That's making things work very hard on the controller's end.
Okay, so you're saying that we look at our voltage up here on this side, and then we look at our ripple, and it should be less than 10%?
Yes, absolutely. A good healthy system would be, 5 to 7% or less. That's a real good, strong system. And we can use the cursor to select, and we can see here that our ripple voltage in this case is 1.31 volts, and our input voltage is 30. So we're running a pretty low percentage of ripple voltage at that point, which is a good system. When we get that real high, it starts heating things up, and everything's working real hard.
Okay, so when we first turn it on, we plug it in, we're going to download. These are really the voltage and the ripple, the first two tabs, are what we should really look at first, just to make sure we're healthy.
Yeah, and we can pull up another one, which is temperature. This is also really helpful when you're first getting that system set up.
Okay, and it's overlaying all the data now. I see all the different bars.
Yeah, we have here, we're color-coded, and we have different scales for each color. Voltage is here in red, and that's our red line. That's going to correspond to this scale. Right. Our ripple voltage is in purple down here, and it's in this. And then we have this almost lavender color over here for temperature. Okay, so then that's that scale. And we, if it gets overwhelming, you can just take those off, and we can just look at one thing. We can look at our temperature over our run. We have one scale here. This system, it looks like, well, let's find out. We can go over, we can select, and we can see on our temperature, our maximum was 101 degrees Fahrenheit. That's really pretty cool. That thing's not breaking a sweat. If your controller gets too hot, this is the temperature of the controller, by the way. The motor temperature at this point isn't logged. So this is the temperature of our controller. And if the controller gets too hot, it's going to shut down on its own. That's going to happen at about 250 degrees Fahrenheit, and that'll beep out a warning code, and you'll see see one of these little bars in our data graph, and it'll say overtemp. In this case, this was a normal turn off and then turn back on, so it says it's a normal boot up sequence.
Okay, so anytime you see that heavy bar, there was an interruption of some sort.
Correct. It was either an error or we turned it off, and then we plugged it back in.
And it's just going to continually log the data until we clear it out.
Yep. It's going to go through and it's going to continually log until it gets full or we clear it out. Or
if it gets full, does it just start to recycle its memory?
No, it doesn't. It just stops.
Okay, so then we have to go in and follow directions and clean it out.
Yeah.
Okay. So we took a look at our voltage, and what is, let's say we're running a really good set of 2 4-cells in there. What should we be looking at?
Well, what's going to happen when we punch it, all batteries are going to have some sag. They're a physical, they're a real thing.
So it's taking away voltage and putting it to the motor.
Yeah, and so we're drawing a lot of power from that system, and so we get these little dips and valleys here are areas of high power draw from the system. If we pull up this tab, the throttle input, this is the scale over here, and in car world, 2 milliseconds is full throttle, 1.5 is neutral, and 1 is full reverse or brake. So we can see that during this big dip, we were at full throttle. Same with these guys over here.
Okay, so that's normal and it should just correspond.
Yeah, that's normal. That's going to happen with all your batteries. If you have a really good set of batteries with really high capacity and discharge rating, you're going to see less of that. And your ripple voltage will also be a little bit lower.
Okay, so as we're looking at this would probably be on a good set of batteries. We're not, we're at 35 and we drop it down to 30 and it's a little bit as low as 25, but then we're coming back up until we use it again.
Yeah.
So this is normal.
Yeah, this is normal operation here. Here, we've got this thing just topped off, and then we punched it and we used some power, and they started to warm up and get used. And so the voltage kind of sags and it doesn't really fully recover. We get around here. If we look, we're at 33.8 volts, so we're down a little bit, but everything's still fine.
And as we use the batteries more and more throughout our run, that's going to continually decline.
Yeah, and you can see, this starting point is a little bit higher, or that ending point is a little bit higher than that ending point. We've used more capacity up.
Okay.
We can look at that too on here. Let me take this out so it doesn't get too cluttered. But we can look at our total capacity used. This is in amp hours. So 1 is actually 1,000 milliamp hours. And so we've used, at the end of this run, our maximum here, we've used 2,280 milliamp hours of capacity from our battery pack.
So if we're running a 6500, we're
good. We're good to go for quite a while.
Okay. Does this give us the amount of time that we ran?
Yeah, down here we have our time in seconds. So over here we're at the 10-minute mark, and we've hit somewhere around 1,800 milliamp hours. So this system is really conservative, especially for running 500 milliamp.
Yeah, got a good long run time on it. Okay, so let's see what else we have to choose from.